Alright, so next we are going to talk about the Fleming's right hand rule. Fleming's left hand rule we have learned in the previous chapter, magnetic effects of current. And here we are going to talk about Fleming's right hand rule. Okay, what is exactly the Fleming's right hand rule? So let me tell you something. That is, stretch your fingers, all the three fingers, that is thumb, forefinger and middle finger, and stretch it and then make it 90 degree to each other. Look at this. This is actually in 90 degree with this hand. This one. This is actually 90 degree with this one. Okay, this one, and all are mutually perpendicular. All are mutually perpendicular. Then the thumb represents the thumb. So I'm not, you know that, right? I'm not good at drawing, so that's why my thumb and forefingers are like that. Okay, so I think middle finger is a little bit good. So thumb, what is actually thumb represents? Thumb actually, it is a force. Okay, thumb is force. Thumb represents the force. And then forefinger, the magnetic field, D, magnetic field. Middle finger, the current, I. So this is actually the thing. So you know have you heard about the famous like the investigation agency FBI of America? You must have heard that. Okay, Federal Bureau of Investigation. So you can think like that. FBI, force, magnetic field and current. And even in left hand rule, we know that velocity is there. And sometimes when we discuss about motion EMF, we have to consider the velocity. Velocity is actually velocity represents the motion. When would we have motion? When would we have motion? When we apply force. So that's like absolutely, by Newtonian mechanics that's not absolutely correct, but for our understanding we can think like that. When I apply force, there will be a motion, velocity. So FBI, so F could be velocity also. You can consider it as F is a motion actually. Okay, so let me give you some examples. So I know that so there will be question like define Fleming's right hand rule. Define. How do you define that? Okay, so stretch all the middle finger, thumb, middle finger and forefinger of your right hand, and then take it and all are mutually perpendicular. Make them all are mutually perpendicular like that. So then thumb represents the force and forefinger represents the magnetic field and middle finger represents the current. Okay, so now let me give you two examples. There are two examples I have given here. So look at this. Here velocity is in this direction. What about the magnetic field into the paper? So I would like to take it as FBI. So already F is in this direction. Look at this. F is in this direction. What about B? So B is in this direction. Into the paper. My forefinger into the paper. What about I? I is, look at this, in this direction. So I is in this direction. I is in the upward direction. Okay. Now what about here? Here this one, magnetic field is outward. Okay. So and force is in that direction. So FBI. So it will be F is in this direction, and then what about B? Sorry, F is in this direction and B is in this direction. What about current? Current is in this direction. Look at this. Okay. So your hand should be very flexible. Okay. So I is in this direction. Okay. If you can imagine it, then no problem. So I is in that direction. So this is actually the whole Fleming's right hand rule. Okay. So don't get confused about this. It's very easy, and we will explain it and we will discuss next motion and EMF. Okay. Thank you.